Good morning, I'm Andrea and I'm going to present the results that I obtained by statistically analyzing the results in Minitab from Vasquez, Martinez and team regarding the shoots per explant of agave tequilana obtained from incubating the explants on different kinetin concentrations. First of all, Vasquez, Martinez and others reported the mean and standard deviations of shoots per explant obtained with 4 different kinetin concentrations. Importantly, there were 8 repetitions per concentrations, which were 0, 4.7, 9.4, and 37.6 micromolar. So the values were randomly obtained with Minitab considering these factors and rounded to its closest entire value. The objective of this essay was to evaluate which level of kinetin concentration increased the response variable, which was the number of shoots per explant. Hence, the null hypothesis was that saying that all level concentrations did not have a significant impact on the number of shoots. In other words, that there was no significant variation in the number of shoots per explant that were obtained at the different evaluated concentrations of kinetin. Meanwhile, the alternative hypothesis was that at least one mean of shoots per explant of one kinetin concentration was different from the other kinetin concentration levels. Considering that the only variable factor was the kinetin concentration, the ANOVA for one-factor factorial design was carried out. Since the p-value of the ANOVA showed a value of 0, the null hypothesis could be rejected at a significance level of 0.05, and hence the alternative hypothesis was true with a 95% confidence interval. In other words, it was true with a 95% confidence interval that at least one mean of shoot per explants of one kinetin level was different from the other kinetin concentration levels. In order to evaluate which of the levels was or were different from the others, the Tukey pairwise comparison was performed. From it, we could say that the kinetin concentration of 0 had a significant difference on the mean of shoots per explant in relation with the 4.7 and the 9.4 micromolar concentrations, which were treatment 2 and 3. Which were not significantly different between them, and with the mean corresponding to the 37.6 micromolar kinetin concentration. With this taken into consideration, a factorial plot was done to see which kinetin concentration maximized the shoots per explant, which turned out to be the one of 37.6 micromolar, although it can be seen that treatments 2, 3, and 4 might not be significantly different enough. The Tukey evaluation confirms that indeed the treatments 2 and 3 differ from treatment 4. Then, to consider these results as reliable, the test for normality was performed, obtaining a p-value of 0.592. Hence, normality could not be rejected at a significance level of 0.05. This means that there was a normal distribution. It could not be rejected that there was a normal distribution. Then the equal variances test was also performed, and with that, the Bartlett method, a 0.044 p-value was obtained, which is lower than the significance level of 0.05, so equal variances could be rejected with a 0.05 significance level, hence there were no equal variances and the ANOVA results validity could be affected. Finally, if the variances turned out to be equal, we could firmly conclude that the 37.6 micromolar concentration of kinetin maximizes the number of shoots per explant in agave tequilana. However, since variances were not equal, this result might not be completely feasible, and another test has to be performed to validate the aforementioned conclusion. Nonetheless, we can still rely on the Tukey analysis and factorial plot, which showed that the 37.6 micromolar concentration was the one that developed the most shoots per agave tequilana explants and is the one that should be used.